Welcome. In this tutorial, we're building a fully functional NFT auction contract from scratch, deploying it on a testnet, and interacting with it step by step using Remix IDE and MetaMask. By the end, you'll understand every line of Solidity, every transaction you sign, and the security decisions behind the design. Our auction allows a seller to deploy the contract while specifying the NFT for sale, a starting price and way, and the auction duration. Bidders can compete in real time, with each new bid needing to exceed the current highest by at least 10%. Once the auction time expires, anyone can trigger the settlement, the highest bidder receives the NFT, and the ETH goes to the seller, with all outbid amounts safely held in the contract until returned to their owners. Let's prepare our environment before we delve into code. You'll need MetaMask installed and some test ETH on the Sepolia network. Open MetaMask and ensure you're on the Sepolia test network, enabling it in settings if necessary. Navigate to sepoliafaucet.com to request free Sepolia ETH by pasting your wallet address. This test currency has no real value but mimics mainnet Ethereum perfectly for our purposes. Pause the recording here until you see the ETH arrive in your wallet. Now, let's turn to Remix IDE. Open your browser and visit remix.ethereum.org. Remix is a free browser-based Solidity IDE. On the left, we have the File Explorer for managing Solidity files. The center houses the code editor with syntax highlighting and error markers, and on the right are various plugins, primarily the compiler and deploy tabs, which we'll use most often. Click the Solidity compiler plugin and ensure the compiler version is set to at least 0.8.20, as our contract utilizes custom errors and immutable variables, necessitating this version. Now, we'll create the mock NFT contract needed for our auction. Click the plus icon in the File Explorer and create mockNFT.sol, a minimal ERC721 contract for minting our test token. We'll import the OpenZeppelin ERC721 base contract, which Remix automatically retrieves from GitHub. Our mint function allows us to specify an address to mint a token and increment the ID counter. Once you compile and see a green checkmark indicating 0 errors, switch to the Deploy tab. Set the environment to injected provider, MetaMask, connect, and check that your wallet address and Sepolia balance appear correctly. Select Mock NFT from the contract dropdown to deploy it. MetaMask will prompt for a transaction confirmation, approve it, and wait a few seconds for it to mine. With the contract deployed, expand it in the Deployed section to locate the mint function. Input your wallet address and click Mint, confirming the transaction in MetaMask. After the transaction mines, you'll own token ID 0, which you can verify with the owner of function. Now, let's get into the NFT auction contract. Create a new file called vtauction.sol and paste in the complete contract. At the top, we import reentrancy guard from OpenZeppelin and define a minimal ERC721 interface. The auction state, an enum, contains 3 values: started, ended, and cancelled. This keeps our code cleaner than using arbitrary integers. We declare several immutable variables: NFT contract, token ID, seller, start price, and bidding deadline, which are set once in the constructor and inlined into the bytecode at deployment for gas efficiency. The constructor requires parameters for the NFT contract address, token ID, starting price in way, and bidding period in seconds. With this, the auction goes live. Next up is the bid function, the contract's core mechanism. The non-reentrant modifier from reentrancy guard prevents reentrant calls during a bid, enhancing security. The bid function begins with checks for auction state and time, reverting execution if conditions aren't met, utilizing custom errors for gas efficiency. Minimum bid calculations derive from either the starting price or the current highest bid, ensuring a strict 10% increase. Before changing any state, we record any previous highest bidder's refund, adhering to the checks affects interactions pattern, a vital security practice. The end function concludes the auction, allowing anyone to call it once the deadline passes. We check the auction state and confirm the transfer of the NFT and ETH to the respective parties, reverting the transaction if transfers fail. The cancel function allows the seller to cancel the auction before any bids. The claim refund function uses a pull payment pattern to prevent external malicious calls from draining the contract. After compiling the auction contract successfully, we'll deploy it, inputting the constructor parameters as per our earlier deployment of mock NFT. Remember to grant approval for the auction contract to manage the NFT. Now comes placing bids. Set an appropriate value and confirm your bid in MetaMask. After confirming, check the highest bidder, highest bid, and minimum next bid for accuracy. When placing a second bid from another account, note how the first bid is still held in pending refunds. Following the 5-minute bidding period, we can end the auction, ensuring the state reflects ended, validating the ownership transfer, and confirming the seller's ETH balance has increased. Finally, your original bid can be claimed back through the claim refund function. To test the cancel functionality, deploy a new auction, calling cancel without bids first, then with bids afterward to observe expected revert behavior. In summary, we created a fully functional NFT auction contract with security practices in place, including the reentrancy guard to prevent attacks, a pull payment system for refunds, and a clear representation of auction states and transitions. Consider extending this contract with features such as royalty support or an allow list for bidders. Before deploying to mainnet, ensure thorough testing and consider a professional audit to maintain security. Thank you for joining this comprehensive tutorial.